Alright, so we just organized that whole thing, and now I have a really comprehensive guideline for my learning. I can follow this to-do list. Everything's just gonna roll right into place. First, okay, so instead of following like a book and just doing the tutorials it wants me to do, I'm gonna do the tutorials in a logical progression that I think makes sense for me. So I created my own curriculum. First, we're gonna learn how to draw a cube. So I'm gonna look up how to draw a cube in my OpenGL book. Then we're going to create code for placing a cube in XYZ. Now, maybe in the book they would have taught you first how to change your camera angle or how to draw a triangle. What if I don't want to draw a triangle? I want to learn how to draw a cube first. So an OpenGL book might not do the things you want to do in the order you want to do them. And I think it's important to do them in the order you want to do them because that's your learning progression, the way you want to conceptualize everything, the answers you need in the order you need them. Code for changing rotation in XYZ directions of cube. Code for camera control with WASD and mouse to look around the cube. So at that point, if we have camera control and we're running around a cube, already it's kind of like a game environment. That's like a virtual environment because you have a cube which gives you reference, and then you're moving around it with your camera, so you're actually moving around in the game world at that point. So that's already just step 4, and we already have like a real game world. That's amazing. Whereas in the example tutorials, it'll just be like teaching you how to draw all kinds of like animations and stuff for triangles by this point. Who the heck cares about animations? Like, that's jumping way ahead, like to step number 50 when we start animating models. I want to learn just how geometry works and how to move around the geometry and interact with it. Like, the logical progression of the tutorials are retarded. And they try to teach you like how to change the color of geometry. Who even cares about changing the color of geometry? The color is going to be determined by lighting effects and texture maps. So why are they teaching me how to make a blue triangle and a red triangle? Like, who cares? Then I'm going to learn how to draw a line. Then I'm going to learn how to code drawing a series of lines to form triangles and triangles to form objects. And the PC will be able to create objects with a series of points by remembering the points and rendering faces onto said points. Yeah. In this way, my AI can draw models to sculpt and trace images. So that's important. Then I'm going to learn how to load an OBJ file into the 3D environment from file, and then save it back to file. And part of that exercise will also entail this whole other write-up I made about saving. So once I load a 3D model, like let's say a cube, into my virtual environment, and then I move it somewhere, and then if I were to close out the game, it wouldn't stay moved. Or I'd have to load up my test program. The cube's there. I'd have to close the program, and then I'd have to move it in code, and then load up the program again to see the cube moved. I don't want to do it that way. I want to be able to move the cube while I'm in the program. So that's interaction with my game world. Now, in order to move the cube, I need to code selection of the cube, moving of my mouse to move its location, moving of my camera to change. If I move my mouse right and my camera's facing north, the cube's going to move east. But if I want to move the cube south, how do I do it if my camera's facing north? Well, I got to face my camera east and then move my mouse right when I click on the cube and move it. And that will move it south. Or I can code, once you select an object, an arrow system pops up with arrows shooting in 2 directions and then in a 3rd direction, Z. And then you can click on that different colored arrow and move it like it is in Maya 3D modeling software. So that's the way you can move objects around. Now, none of the moving objects around really means anything if it's just being moved around and told to be rendered in the new location. So I need to be able to save where I moved it so that the next time I load the program, it's in a new place. That's how you create game worlds. You have to be able to save where things are. So at that point already, before I'm even getting into model animations and stuff, which is stupid to do at that point, I want to be able to create objects, sculpt them, and then move them around and import them, modify them, and move them around. That way I can start creating my game world right away, way before animations even enters the picture. Then I also want to instruct like the order things are rendered in it, and the order things are loaded in, because it'll be saving all these locations of all these objects to a file. And how do I want to name that file, and what is that file about? That file is my campaign file, and it defines where everything is in the world. And I'm going to have a second file that shows where everything is just real close to my character. And so that way, when I launch my program, it will render the things real close to me first. It won't have to download the entire list of where every object is in the entire world. That would be longer. That will take time. So it will do that after it loads all the media items from the close to me items file. So that will be two separate files. I guess the way a real big world does it is they'll have zones, and when you cross into a new zone, it will load everything in that zone. But I don't think my game will be that big that I need to do it that way. Plus, by the time my game's released, everybody's going to have a solid state drive. I don't think my open game world is going to be like ridiculously big to the point where I need to zone it all. It's going to be like the equivalent of 2 zones in like a big MMO. So like that's going to be my entire game world for multiple games that will all take place within those 2 zones. So like in a MMO, you do a bunch of quests in a zone. Well, if you were to take 10 of those quests, you can make a whole video game of those quests. If you had cinematics and stuff, like that's gameplay right there. So an entire game can take place within like a single portion of a single zone of an MMO. That's how big MMOs are. But they just make this enormous open world, and there's very few cinematics, and there's thousands of hours of playtime, whereas like a single player campaign game with the multiplayer mode is much more small in scale as far as total hours you can spend. So the game world can be a lot smaller because you're not covering that much ground. Code for applying texture map. So that now we're getting into textures. With the normal progression of tutorials, they teach you how to do textures on your stupid cube, or yeah, on your stupid cube, like right away before they even teach you how to save world maps and relocate items and all this stuff. So I'm doing it in a way that is like, I think, way better than the way it's normally taught. Because already by like step 6, we've got ourselves a game world, we've got tons of objects, things are coming together, it looks like something's happening. Whereas by step 6 in these tutorials you find in programming books and on websites, all you have is just a rotating triangle that is changing colors and causing you cancer. Like, I would much rather have like my game world already coming together as I'm working through these steps of learning. Code for applying texture, code for high-end lighting. So now we get into lighting, and custom shaders are an option at this point. I can explore off-the-shelf ones and reviews on them and stuff, or I can write my own. And I can also explore the quality of just default lighting. If you just tell the video card, like, here's a light, here's the direction I want you to point it. See, like, what kind of ray tracing does that do? What kind of quality is it? How realistic is it? And then determine if I need to code my own shaders. Code for shadows. If I made my own shaders, it would automatically create a shadow because light wouldn't shine where shadows are. That's kind of a red flag. Like, how can there be a light that doesn't cast shadows? So the lighting typically used in these tutorials is kind of sketchy. It's like, why doesn't it have shadows in it? But if I created my own ray tracing light, like that would definitely have shadows. Code for reflectivity, code for applying various special types of texture maps. code for MIP maps, so lower resolution depending on how far away. So you have like multiple versions with different resolutions of your texture map. Code for showing FPS in the corner, so that's important as I start populating my world. I need to monitor my FPS, and if it starts dipping, I can like know I need to optimize something I added. So if we're taking huge performance hits, that will kind of clue us in quickly so we don't move on and we'll be like, oh, that thing I just added, that new shader, it just screwed my FPS. So I think that's important pretty early on in the development cycle to already start monitoring that so you can make sure you don't have very buggy or inefficient code being introduced over time. I want to try to keep it to like 120 FPS at all times, as long as possible. Code for outdoor scene full. So at this point, I'm like, I got all the tools I need. I'm going to make a full outdoor scene. And I'm going to copy Assassin's Creed, the Rad Brad video on YouTube, which had like a really cool outdoor scene, which kind of looked like the same type of setting that my David game would have in an outdoor world. And I also had another outdoor scene I could pull from. Yeah, my outdoor scene needs to be better than Assassin's Creed's outdoor scene. Oh, I want to use also Shadow of the Colossus game as an outdoor scene reference because I really thought that was beautiful how they did it. That game had amazing graphics, the remake for PS4. So I'm going to pull those two as reference, but mine needs to be better than both of those. Why? Because my game's coming out 20 years from now. Every game's going to be 10 times better by then. So mine has to be way better than all the games out today, because the games out today are going to look dated. So I can't use those as a benchmark for my quality. I have to be way past AAA quality for my game to look even decent 20 years from now. Code for indoor lit house scene. Then we'll do a cave firelight scene. So this will be all different types of like lighting effects we'll be exploring in these different types of scenes and different challenges each one will present. Code for a shower scene, or sewer scene, I should say. I wanted to pull industrial lighting and copy a sewer from The Strain, which is where the final episode was on The Strain, where the sun dies. I thought that's like a perfect creepy type of scene location that they had, which would be great for my zombie game. So I'm going to pull a reference from there. Create outdoor dark out city streetlight scenes that will introduce like starlight, moonlight, and streetlights. And so that's all going to have challenges as far as creating really nice lighting. Code for atmospheric effects for focus on foreground, blurry background. So basically, depth of field. The further away things are, the more hazy it should look. And that way it looks like a camera that's focusing really sharp. And that makes it look like really awesome. Expensive webcams do that, or expensive video recording equipment in movies and stuff will have that. And I want that to be how it looks in my game. So everything far away will look a little more blurry. I have to implement that. Code for blowing sand atmospheric effects, like on Last of the Colossus Desert. I really liked how they did the sand blowing on that game. Code for sun shaft effects, lens flare. I love the sun shaft effects on Shadow of the Colossus in the temple where you have all the cinematics happening, so I definitely will use that as inspiration to make sure mine's at least around that good. Or actually, it's got to be better than theirs. Code for falling rain. Code for water puddles and ripples. Concentric rings that travel when you splash into it. Code for lake water. Probably have to do all my own shaders to create really realistic water. I want to go for like Despicable Me 3, where they show water. I was amazed by how nice it looked, so I want to go for that level of quality. I think that would hold up 20 years later. It looks pretty real to me, honestly, so I'm going to go for that. Code steam, like from a shower, so I could have steam coming up off the water, like mist blowing up when a wind kicks up, so that would look pretty cool. Or like steam if I want to have like somebody walking out of the shower as part of a scene. Seems like a lot of zombie movies, somebody just got out of the shower. So I might have a scene like that. It's not going to show them in the shower or anything, but just steam is a cool particle effect I want to be able to produce at will. Or like steam coming up from a sewer grate in a night scene. That'd look pretty cool. Code for fire, including little flecks of embers floating up from the fire. Code, so that's like a particle effects type of thing you would code directly into a shader, I believe. So your video card would calculate the fire. Code for blowing dust and crap in the bright light. Oh, you know what? I should add for the fire code for explosion. So we should be able to have big explosions. That's kind of like a combination of fire and steam. Or smoke, we should say. I think steam and smoke's the same thing, though. Code for blowing dust and crap in bright light. So like the sunbeams will have dust blowing around into them. Code for animating an object with interpolation and blur. Code for animating foliage gently blowing. So see, we're way down the list of rendering engine tasks by the time we're doing animations. In the stupid triangle tutorial, day 1, they're already teaching me animation. Like, that's way outside the scope of what they should be teaching you right away. These books are so stupid at the order they teach you in. Code for glass of water. Code for 2 main first-person characters full. Plus, the way they teach you to animate, they're like, rotate and then a rotation speed sent to the renderer. Like, rotate and rotation speed, that's stupid. Like, my game is not going to use some off-the-shelf rotation like command for a specific object to animate it. Like, my animation system has to be a complete system, and it would not be done with just a generic rotate the object around its axis, which is just chosen randomly. Like, that's such a stupid animation to even use in a real scenario to begin with. Like, rotating around an axis, just a spinning square, like why would anyone want that? And like I said, I need AAA quality goals and way beyond that even. If my game's coming out 30 years from now, it has to be way better than anything out today. Way better. Even engines like Unity and Unreal or whatever, if you fast forward 30 years from now, they're going to be so advanced that even amateurs making games will have access to all this stuff built in. So my game has to have way better stuff than Unreal or Unity can even offer. Okay, code for glass of water, animated foliage, sunshaft, explosion, dust, animated object with, okay, animations are here, like we talked about, animating foliage, glass of water. Code for 2 main first-person characters full. Okay, that should say third. So just like The Last of Us or Assassin's Creed or Shadow of the Colossus is in third-person view, that's how my game will be, because I'm copying that type of game. And we're going to create 2 main third-person characters full because we're having 2 different video games we're building at the same time. One's the zombie game, one's the David game. And we're going to create their models and create their clothing, create their look and everything at this point in time. And we're going to have them be animated and be controlled by you. Although, well, initially the animations will just be real sloppy, like rough animations, not involving like my physics engines, because that's not even made yet. This is just the rendering engine, but we're just going to add it in so that as we continue making things in our game world, rather than just being the part, when you're making the game world and you're in the game making the world, I'm not going to have it where you sculpt stuff in Maya and then you export it as an OBJ and then you load up the game and then you import it into the game. I'm not going to do it that way. I'm going to have you're logged into the game and you import JPEGs and you use those JPEGs to sculpt models by hand yourself, or you can auto sculpt the models using algorithms that I'm going to create that will be able to convert a 2D image into a model. And then it will also, I'll have algorithms for creating textures for the models. So that way, all game assets will be automatically generated. So it's not going to be an art project where I sit there like sculpting hundreds of different items to put as assets in my games. Instead, it's going to be my game automatically converts images I get from Google Image Search into working 3D models and bad guys and everything. And it can also create totally new stuff, like just like how on a video game you can have a character creator and make their nose longer and stuff. My algorithms will be able to modify models so that I'm not just copyright violating any models that I were to download from a free model library. Plus, it will be able to generate models completely from scratch from the ground up as well. But I think 3D models will have really nice contour lines and be really well executed and form great base models, which will be easier than having the algorithms create the models from scratch. But it will create models from scratch as well anyways. But we're just going to have a combination of the two. So all the models will be created in my program. My program will then automatically save as changes are made in the game world. So we're not going to create models in 3D modeling software or ZBrush. We're going to create them all within the game itself and then save them as OBJ files, export them out of the game, and then export also all their textures. And that will automatically be exported as autosaves frequently. And then you can move the models. So I'm actually going to create a workshop in the game with a table in it that I'll create everything in. Small scale models on my table. So I'll have an actual character that it's like I'm having a game inside a game. So it's almost like Minecraft in that way, where I'm the game dev and my main character in third person view is creating the game. He's the Minecraft character creating the world around him. And on his workshop table, he's using algorithms and stuff. He can press like a button and an algorithm will be unleashed that will model a model for him on the table. And it will all be in small scale, so he can create cities and buildings and all kinds of things and characters and assets all right there on the table. And he'll also do that by importing JPEGs, which will be read in by the algorithms, interpreted, and then 3D models are automatically generated from those JPEGs. So once he creates a 3D model, he can then put it in the back of his pickup truck. So he'll run outside of his workshop and he'll actually throw the 3D model in the back of his pickup truck, and then he'll hop in the driver's seat like Grand Theft Auto. He'll hop in and he'll drive around dropping off models throughout the game world. He can drive really fast and he'll get out and throw the model down, and then he'll scale it up, and then he'll get back in his truck and drive away. So it will be like a video game for me in that while I'm creating the game world, I'm actually a character in that world that's like a god, making everything and driving it around and putting it wherever I want to put it. And it will be cool conceptually, like to have my little central base at 000 coordinates that my little workshop's located at, so I can always find it. And I can teleport around the world too if I wanted, but I really like the idea of like, rather than like mouse zooming or using WASD, like to create just like a moving around in the world with just this disembodied camera, and I'm just like floating around like a ghost. Instead, I get to be a character and actually drive around the world. I feel like that will be like more immersive for generating the world. So you, the game developer, will be the main character of the game, making your own world with your own little shop that's located within that world, that all the 3D modeling, texturing, animations, everything's always created in your little shop. So I think that's like a really cool way to do it. Yeah, so that's how I'm going to do it. And so that's why I have to create the main character. So that, and then when I'm in dev sandbox mode and I'm making my game worlds, the main character for the game will have on his back a sign that says developer or dev, like a big placard on his back. And that will just be an indication for people watching like my gameplay. We'll call it gameplay. I don't know if it's gameplay or if it's development streams, but when they're watching my development footage, they'll be confused. Like, why do I see a character running around in the game world? Is he playing a game right now? No, I'm not. I'm actually creating my video game. But it looks like I'm playing a game because I'm creating the video game as a player in the game, using the game to generate the game and create the game. It's almost like Roller Coaster Tycoon. Um, you're like creating, like a game could be creating a game. Like in that case, you're creating an amusement park, but then, or like Age of Empires, you're like creating your encampment and you're farming for stuff and whatever. That's the game. So in a way, I'm copying that concept of my game development project will all take place, or the majority of it will take place within that game. Um, I'll only have to exit the game for doing actual coding, but for all the asset generation and distribution to create the game worlds, all the visuals will happen within the game world. So that's going to be how my map maker functions, basically. All right, so after I've done the two characters, I'm then focused on creating hair that blows in the wind. That's going to use the GPU. All right, so that came up twice in my notes or my plans, a discussion of hair making. So I had to just paste the notes on hair making, the design for the physics of it, and how the graphic card is going to render the effects of gravity and momentum and wind effects on the hair for very realistic blowing hair on my characters. I put that note of how that's all going to work next to here. Okay. Sweat on the skin. That brings a lot of realism. I believe that's just a matter of adding specularity for the sweat. Reflectivity. Code for animated third-person perspective running around scenes with main characters full. Alright, so up here when we said to make the main characters, that's separate from then moving on to animating them and running around. I want to make a note though. At this time, we will not have finished the physics engine-based animations of running and walking. So this will be just a placeholder normal animation that will not be that cool. Okay. And so then we'll have our little character that we can be the game dev on. And then code for fonts, which is important so that we can create like the game menu and the UI. So rendering fonts onto the screen. Code for sheep, because that's a very important part of a game about a shepherd. David was a shepherd, at least initially. So that's kind of early in the game. Code for facial animation. That's going to be huge. Code for blood spatter animation, sticking to walls, guts spatter, chunks of meat. That's really important for a medieval fighting game and for an FPS game, I think. Just have blood everywhere. Code for flowing clothing. Oh. We gotta put our notes on that too. Putting certain code twice on my to-do list. Or certain notes twice. Great, Samson-based guy. Okay, Samson's the main protagonist on David. Well, actually Saul kind of is, but the fight between David and... Why am I saying Samson? It's Goliath. The fight between David and Goliath is the most epic thing. That's going to be on the cover of the game. So... yeah, that's going to be like the gameplay trailer, thumbnail, and everything. Is David throwing his rock at Goliath. So that's a really iconic imagery. And I'm going to create the Goliath guy based on Brad Pitt stabbing that one guy on Troy, except I'll add a big beard, which we can pull from, I believe his name's Jason Momoa. He has a cool big beard. I think his Ice Poseidon? No, is that? No, Ice Poseidon's a streamer, but isn't he in a movie called something like that? No. He's in a movie about a fish god. Is it called Poseidon? I don't know. No, it's called Aquaman. There we go. I'm gonna add that note. Big beard, which we can pull from Horse Lord King on Game of Thrones, Jason Momoa as Ice. No, not Ice Poseidon. Aquaman. He had a cool beard. So we'll copy his look for Goliath, but we can't make it look just like him because that's copyright violation. You can't make a game look like a real life celebrity. They can sue you for that. Create scary cyborg zombie based on Ghost in the Shell scary spider girl combined with undead and WoW and give it glowing Terminator eyes. Also pull from the ring girl with the black hair and the white robe, but tatter the robe a good deal and a lot of dirtiness to the clothes and bloodstains. So that's going to be kind of like the look for my cyborg zombies. That will be like the iconic zombie, and then everybody else will be kind of that same look. So that's kind of the art direction. Create cool Samson versus Goliath. It's David and Goliath. I was tired when I wrote that. David versus Goliath poster for game cover and website cover action shot. I should say, and game menu. And I'm thinking I'm probably going to pull inspiration for that from like books, book covers, and other artistic renderings of that scene of David versus Goliath, and David's got the sling, because there's been a lot of artists that have done paintings and artworks based on that, so I can kind of pull from those to see what the coolest ones were and then copy them, but not copy it to the point where I'm plagiarizing, just copy it to the point where I'm like stealing what I like from their art. So that's everything for my OpenGL rendering engine. And that's like a step-by-step to-do list. And it starts from really easy, just drawing a cube, and it gets harder and harder. And that's totally doable. Just breaking it down little by little. And then somewhere along that time, we're going to be getting more and more into physics and stuff. Like for blowing dust and grass, we're going to get into some physics there. But I have a whole nother to-do list for the game where it gets into like other really complicated stuff, and more on that to come.